value function, and you just tell me about it. Or I give you a linear or quadratic and make you take the absolute. I didn't notice those until now.
Which is the best? Which one's the best? The one to the left. The middle one actually below.
They're all. The middle one looks like a pirate. Just like it just needs like a block. It needs a block to put its foot on. Left one I feel like is Tegan because it's a different color and therefore I don't want to pick it and shame Raymond. Okay. I picked the two outside ones, although I appreciate the middle one because it looks like a pirate. Can I draw a block underneath?
Gabby do the blue one and then Chloe does on the yeah, it's not very even still.
You know what? I'm not narcissistic. Okay? That's pretty easy. You see this by inner core. Thank you. Well, I decided to give him a peg. I was going to make him have it on top of a block, but then I decided to give him a peg. Like,
where's the fire patch?
If Sam ever watches this, he's going to be like, what is going on? It's fine.
Let's draw one on the front. Let's see Miss Lepp among this dog. Yeah. We just give it one time. One time. Come on, please. What's up?
It's the end of the year you have.
Then you can ask Sam.
It's not the end of the year.
Yeah,
There's time.
Yeah.
I'll practice some on the weekend and get better at it. And then I will produce an Among Us at some point in time randomly when you least expect it. Okay. Still have not talked about anything. Nothing math related for 1 minute and 47 seconds. All right. Okay, so here we have an absolute value function is a function that involves the absolute value of a variable. Much like how we took the reciprocal of a function, we are going to take the absolute value of a function and see what it does. To graph an absolute value function, we can use our calculators. We've talked about how to punch it in. And we're going to move over. So I want you to graph 2x plus 1. This is grade 10. We don't need our calculators. We're just going to graph it. What is this? What's the constant always? My y. There we go. My y-intercept. And that's like my starting point. So remember in grade 10 you're taught that's your y-intercept and it's like your starting point. It's like this is home. And then I use my slope to do the directions to find another place. Okay? So 0, 1 is home. So that's going to be, I'm going to pretend that's my home. 0, 1. I'm also going to say x scale 1, y scale 1, because I need to tell people looking at this that each of those is 1 without having to go 1, 2, 3 and number them. Okay, so that's my starting point. That's my home. And then I use my slope to find where I'm going. Correct? So this is 2 over 1. So my slope is 2 over 1. Do I rise before I run to get out of bed or run before I rise? Run before you rise, you look like an idiot. You're just in bed running and then not going anywhere. So what do we do when we get out of bed? We rise and then we run. We agree? So if this is a plus 2, we're going to rise 2, and then we're going to run right 1. Now what did I tell you about these? We could also do the complete opposite, correct? Because if this is a minus and this is a minus 2 and a minus 1, bless you, negative 2 divided by negative 1 is positive 2. We agree? So that's why your slope can actually go the complete opposite direction as well. So I'm going to go to my home, and they told me to find the place I want to go. I have to rise up 2, run 1. So I rise up 2 from my home, run 1. Rise up 2 from my home, run 1. Rise up 2 from my home, run 1 to the right. Then I told you we can do the complete opposite and we'll still land on it, right? Because negative 2 divided by negative 1 is positive 2. So instead of going up to right 1, we're going to go down to left 1. And we know we did it right if it continues to line up on the line. Down to left 1, down to left 1, down to left 1. Okay. What is my y-intercept? To fill in here. 0. What was it? 0, 1. Is there a minimum value? No, none. It's just a line. What's my x-intercept? When I think x-intercept, I should think y equals 0. If ever anyone says x-intercept, you should scream at them, y equals 0. And they'll be like, what's going on? That's what you should scream, because that's what should pop into your head immediately when someone says x-intercept to you. Y equals 0. You should scream it at them. They should be scared. That's how fast you should think about it. Okay? So we're filling y in for 0, 0 in for y. So we're going to get 0 equals 2x plus 1, and then I need to just solve for x. So I'm going to subtract 1, and I get negative 1 equals 2x. Divide by 2. X equals negative 1/2. So I get negative 1/2 and 0 as my x-intercept. Bless you. What's my domain and range of a line that just does this? Yeah. I was waiting for him to say, could I have the notes, please? But he didn't ask. Just because I started speaking a little bit in British, you guys were like, it's Ted's birthday. Happy birthday to you.
Ted? Anybody else?
No, but it's his podcast. He has to watch it. Let's listen. Let's sing. Happy birthday to you. Happy. Okay, go.
Birthday to you. I can't do it. I can't.
Yeah, he's right. I'll go with you. Happy birthday
to you.
Happy birthday, dear
Sir Edward Ted. Happy
Happy
birthday to you, proper man.
Yay! We'll sing Chloe off.
You proper
Sing
little
to Chloe
chap.
off of the
Rip it up on the turf today, brother.
Oh my. Okay. What's the domain of a function that does this? XER? And what's the range of a function that does this? Range. Right. Y. So we have x such that x an element of the reals. And then the set of y such that y is an element of the reals. Now we're not going to do the absolute value right away because we need to practice our grade 10 math skills again. So you're going to graph this down here and go. And then fill in all the rest. You're going to fill in x-intercept, y-intercept, max values, domain, range. Okay? So you're graphing this one now. The one next. So we change it to x plus 0 squared, so it's going to be at 0, 5. Then we go to our table of values. And we pick other ones off the side. So we have like negative 1 and 4.5. Negative 2 and 3. Negative 3 and 0.5. Negative 4 and negative 3. And then negative 5 and negative 7.5. We're too far off. Okay, so that's that side. Then we go the other way. 0, 5, 1, and 4.5. It's symmetrical, so it's just going to repeat on this side. Now, for these graphs, you have to know the x-intercepts. Okay? So x-intercept means y equals 0. We know that. So we're going to go 0 equals negative 1/2 x squared plus 5. I'm going to do it down here so I have space. So I'm going to go 0 equals negative 1/2 x squared plus 5. Then I need to isolate the x squared. Now you move everything to one side. You could set this into the quadratic formula. Your a would be negative 1/2. Your b would actually be 0, and your c would be 5. So if you were stuck, you could always do that. But because this one doesn't have an x, I can just isolate the x squared. So I can subtract 5. And I get negative 5 equals negative 1/2 x squared. Then I can multiply by 2. I get negative 10 equals negative 1x squared. Divide by negative 1. And x squared equals 10. And then when I take the square root of 10, what do I get? What should I always get in front of here, though? In front of the square root sign. Plus or minus. So I'm not going to turn that to a decimal. I'm just going to say x equals plus or minus root 10. So my x-intercepts up here are negative root 10 and 0. And root 10 and 0. So the decimal to that is actually what's on the graph here. So I'm going to go negative root 10 and 0 is this one. And then this one is root 10 and 0, not drawn to scale-ish, because it looks like it's on 3, but it's not. Bless you. What's my y-intercept? When you hear y-intercept, what should you immediately think? X-intercept, you scream at my face, y equals 0. When it's x-intercept, you scream y equals 0. When it's y-intercept, you scream x equals 0, which is why it ends up being the constant. So it's going to be y equals negative 1/2, 0 squared plus 5, so that's why it is just the 5. It's going to cancel everything off. So this is at 0 and 5. So when you hear x-intercept, you should scream y equals 0. When you hear y-intercept, you should scream x equals 0. It will be helpful for next year. Okay? The max value we found was 0, 5. My domain is x such that x is the name of the reals. What's my range for this one? Y such that y is 5. Yeah. Y, yeah. Okay. If it was a reciprocal function, we kept the x's and we went 1 over the y's. We agree? If it's an absolute function, we keep the x's and we actually take the absolute value of the y's. So all the negative y's are going to become positive. We agree? So when you take just a linear or a quadratic and you take the absolute value of it, it takes the entire graph and makes it at 0 or above. Okay? So let's go back to the linear one here. So this one here, my mapping is going to be x, y becomes x absolute value of y. Remember how mapping for reciprocals was x, y becomes x 1 over y? This is x absolute value of y. So I can use any coordinate on there, and I can change it. Now, why is the x-intercept so important? Is the x-intercept going to change? If I go negative 1/2 and 0, and I take it and I get negative 1/2, the absolute value of 0, what's the absolute value of 0? 0. So does it change? No. So that one's going to stay. What about all the positive values? So like 0, 1 is going to become 0 and the absolute value of 1, which is still 0, 1. And then I take 1, 3. I'm going to get 1 and the absolute value of 3, which is 1, 3. Do you see how none of the positive y values are changing? And 0 isn't changing, because the absolute value of any positive value just stays the same. We agree? I have one more, or two more. 2, 5 is going to become 2 and the absolute value of 5. So I get 2, 5 still. And then 3, 7 becomes 3 and the absolute value of 7, which is still 3, 7. What's going to happen, so I'm going to put a line through these with an arrow because it would keep going. What's going to happen to all those negative y's though? They're going to become positive, so it's going to actually make that B graph again, that absolute value graph again. So let's try those ones out. So we have negative 1 and negative 1. It's going to become negative 1 and the absolute value of negative 1. So that becomes negative 1 and 1. We agree? So now we're going heading this direction. Oops, I don't know why I just drew it on there. And then we have to do the next one, which is negative 2 and negative 3. So you become negative 2 and the absolute value of negative 3, which is negative 2 and 3. So what coordinates stay the same on these when I take the absolute value of a function? What coordinates stay the same? When the y's are positive or 0. And then which ones change when the y's are negative? Okay, one more. Let's do negative 3 and negative 5. It's going to become negative 3 and the absolute value of negative 5, which is negative 3, 5. So did my x-intercept change? No. So it's going to be negative 1/2 and 0. My x-intercept is never going to change. Did my y-intercept change in this one? It's 0 and 1. So it didn't change. When will my y-intercept change? When will my y-intercept change? When my y-intercept is what? Negative. When my y-intercept is negative, it'll turn positive, right? So because this one was positive, it didn't change. That's my minimum value. The x-intercept. Negative 1/2 and 0. What's my domain of an absolute value function? XER, right? Because it goes out to the right, or left forever, and right forever. What's the range of this one going to be? Y such that y is greater than or equal to 0. Caveat for a second, little side note. If these are on the graph of f of x, and then I take the absolute value of f of x, what will happen to this coordinate? It will stay the same. What will happen to this coordinate? Stay the same. Is the absolute value 5 is 5. What about this one? 6 and 3. This one will change, right? What about this one? Same, because the absolute value of 0 is 0. So the only ones that change are when your y's are negative. Okay, off of this graph now, I want you to sketch the absolute value. So this top part is going to stay the same. Well, my x-intercepts will stay the same. And what will happen to these arms down here? They're going to actually bounce up. So you're going to have like almost like a W. Okay, try it out. Basically, this coordinate and this coordinate will stay the same. So will this one, and this one, and this one, and this one, this one, this one, and this one. Those will all stay the same because they're either y's are either 0 or positive. We just proved by a little caveat up top that when they're zero or positive, they stay the same. So basically, the only ones I have to work with are the two ones below. Because remember, my xy becomes x absolute value of y when we use mapping. So it's going to be xy. That's a lie. What's my xy? It's going to be 1, 2, 3, negative 4, negative 3. Is going to become negative 4, comma the absolute value of negative 3, which is negative 4 and 3. So now it's upwards. And then this one is at 4, negative 3, which is 4 and the absolute value of negative 3, which is 4 and 3. Because remember, the absolute value is just the distance from 0. So that's why it always turns positive, because distance is positive. So we go to 4 and 3. And we have it doing something like that. So everything that's above the x-axis and on the x-axis will stay the same because their y values are 0 or positive, right? Then all the values will flip. So my x-intercepts, did they change? No. Root 10, 0. Negative 10, 0, 10, 0. The x's don't become positive, the y's become positive.
Oh, okay.
Y-intercept stays the same. Why did this y-intercept stay the same? No, what are we changing when we take the absolute value? We're changing the y, correct?
Yeah.
And my y is already positive, right? It's 0, 5. So if I take the actual 0 and absolute value of 5, it's still 0, 5. So the only time your y-intercept is going to change is if it's negative, right? My minimum value is y equals 0. It's the lowest my y goes to. My domain, even though there's a bump and arms going out, it's like forever, keeps going, then forever, right? So every x value exists in this graph because it keeps going forever. It's just all above now. So the domain is going to be x such that x and m in the reals. What's my range going to be? Y such that y is, when you look at that graph, where's your y values? Greater than or equal to 0. When is your test on this?
Monday. Monday.
Tuesday.
Starting on Monday.
Now, remember that on this test you have reciprocals. You have absolute graphs where I just give you an absolute and ask for transformations and domain range of it. You have solving absolutes where you have to do case 1, case 2, and then check them. And then you have where I give you a function, you have to take the absolute value. So reciprocal kind of fits in the same thing as this. I give you a function, you have to take the reciprocal of it, or I give you a function, you have to take the absolute value of it. And then there's solving absolutes. And then there's ones where I give you the equation of an absolute, and you have to give me the transformations or domain and range, right? So, the homework for this one, 7.2.
Oh, that's so cool.
And I want you to do number, or page 376. Number 5B. 6 will say take the absolute value, sketch graph of the absolute value of 2x minus 6. So the way to sketch that is you can either put in your calculator and sketch it, or you can sketch 2x minus 6 first, and then take the absolute value like we just did, right? So we'll do 6C, 7B. Oh, I lied. I want 7A.
Okay.
Pranked you. And then HC. 4 questions, people. 4 questions.
4 graphs. Thanks, Don.
So, the sections that you should be studying, if you were wanting to study, which you should study, are 7, chapter 7, the whole thing. 1, 2, and 3 in chapter 7 are absolutes, and then 7.4 is reciprocal.
So everything in
Chapter 7. Chapter 7, the test will be on Tuesday.
That's the same as lesson 7.
Yeah. So there's 2 little note booklets. There's a reciprocal note booklet and then an absolute note booklet.